Hi guys, Mr. Grachik here to take you through Lesson 2, Temperature. You should have all of your questions done at this point in time from pages 112 to 119. If you don't, pause the video, don't go any further, finish those up before we go on. If at any point in time if your stuff is done, you can stop this video, make corrections to your answers as needed. Let's get started. In Lesson 2, we were learning about temperature. This morning it was so cold outside when I milked the cows, I got ice cream. Ba-dum-bum. It's so cold outside that last night when I drank my soup, I chipped my tooth. Guys, for real this time. It's so cold outside that teenagers no longer have to worry about zits. They are now having to worry about goose pimples. What is going on here? Leave me be. Please turn to page 119 of your textbook and we're going to go over your lesson review. Questions 1 and 2 ask you to look at some vocabulary words and write a sentence using both of those vocabulary words that demonstrates your knowledge of each of those words. The first word is kinetic theory of matter. The second word is temperature. Kinetic theory of matter states that all molecules, no matter what temperature they're at, are in motion. And temperature is a measure of the average motion taking place. So here's my first answer. The kinetic theory of matter says that particles that make up matter are constantly in motion. The average kinetic energy of those moving particles is how temperature is measured. In question 2, we're looking at the word thermometer in degree. Now, a thermometer is a tool used to measure temperature, and it's filled with different liquids. Back in the old days, they filled it with mercury, but that was a dangerous liquid. Today, they're filled with alcohol. And depending on the temperature, if it's warm out, those molecules expand and shows a rising in temperature. If it's cold out, those molecules contract and you see different lower temperatures. A degree is an interval that we count up at. So the answer to question 2 is a thermometer is used to measure temperature and is often marked in degrees. Question 3 deals with one of our key concepts. And we're going to be relating two ideas in this next question. Question 3. Describe the relationship between temperature and kinetic energy. Temperature measures the average kinetic energy of a particle that makes up a substance. So if I was measuring the air in this room, we're measuring how quickly that those molecules are in motion. And if I go outside right now, we know it's really cold outside. Those molecules aren't quite moving as fast. Question 4, it's an apply question. Particles in warmer substances have a blank average kinetic energy than particles in a substance when it's colder. I kind of just talked about that. So if the room is warm versus the room being cold, let's think about how those particles are moving. We have a higher average kinetic energy when the room is warmer. The 5th question asks us to identify what are the 3 scales used to measure temperature and what are the units of each scale. Remember, this is a 2-part question. I hope you got both of them, both parts. Let's deal with the first part. What are the 3 scales used to measure temperature? Well, we have Fahrenheit, Celsius, and Kelvin. The second part of the question asks us to look at the units of each scale. Well, we measure Celsius in degrees Celsius. We measure Fahrenheit in degrees Fahrenheit. And Kelvin, we don't use the degree symbol, it's just kelvins. In question 6, we need to use these 2 boxes, box A and box B, and we have to compare them in order to answer the question. So let's just look at box A. If you look at the particles in box A, they appear to have a longer streak following them, whereas in box B, the streak is a little bit shorter. So I can assume that the molecules are moving faster in box A than in box B. Looking at question 6, which illustration represents the substance at a higher temperature? Well, higher temperatures mean they're more excited, they have more energy. You should have chose box A because the particles are moving faster and thus have a higher kinetic energy. Question number 7. Predict what would happen to the particles in illustration A if the substances were chilled. What would happen if the particles in illustration B were warmed? So it's a 2-part question. Let's take the first part first. It applies to this box A. Remember, it's moving really fast right now. So what would happen to the particles in this substance if it were chilled? Well, if it were chilled, the particles would, on average, slow down. The second part of the question, box B. What would happen if the particles in box B were warmed? Remember, they were moving kind of slow, so they were cool before. So if we warmed them up, the particles on average would speed up. Question 8. Using your knowledge of the difference between the 3 different temperature scales, what do you think would happen if a human's body temperature was 98.6 degrees Celsius? Why do doctors worry more about a fever of a couple of degrees Celsius than a fever of a couple of degrees Fahrenheit? First things first, 2-part question. In the red, what do you think would happen if the human's body temperature was 98.6 degrees Celsius? Remember, our body temperature is 98.6 degrees Fahrenheit when we're healthy. So I'm going to draw a line here on the Celsius scale where 98.6 degrees is, and I'm going to continue it through the Fahrenheit because we're comparing those two. So 98.6 degrees Celsius is pretty close to the boiling point of water, and that's pretty high, almost 210 degrees Fahrenheit. So you can imagine what would happen to a body if we had that kind of temperature going on. So the first part of the question, 98.6 degrees Celsius is much hotter than 98.6 degrees Fahrenheit. A human would not be able to survive at that temperature. The second part of the question, in the blue, why do doctors worry more about a fever of a couple of degrees Celsius than a fever of a couple of degrees Fahrenheit? Well, doctors worry more about a fever of a few degrees Celsius because of the difference between the degrees and Celsius scale. It's much higher than the difference between the degrees and the Fahrenheit scale. So there you have it, guys. That was our lesson review. Be sure to go back and review and change any answers you need to. Ask your teacher some questions and follow your teacher's directions from this point on. Have a great day. You see, the soup was frozen. Frozen because it was so cold outside. The molecules were packed together, so when I went to drink my soup, it was ice cubes. Ice cubes. They chipped my tooth.